Welcome in. I have a sample AP Chemistry short FRQ today. So on the actual AP Chemistry exam, you will have 7 FRQs for the FRQ section, 3 of them called long FRQs, and 4 of them called short FRQs. And for the whole 7 questions, you get an hour and 45 minutes. Now they recommend 23 minutes per long FRQ, 9 minutes per short FRQ. Really, you can allot that time however you want, but that's sort of what they recommend for a good pace. So if you would like, pause the video and try to solve the different parts of this FRQ. And if you'd like to time yourself and give yourself about 9 minutes, that would be a good pace to do this question. And then I'm going to go ahead and go through the solution in under 9 minutes myself. So we are comparing the elements phosphorus and sulfur, which are right next to each other on the periodic table. So part A asks which element has the larger atomic radius and wants us to justify our answer using Coulomb's law. Okay, so as I talked about in my previous video on the multiple choice multi-question set, was kind of a similar question, but was multiple choice. And we talked about how atomic radius decreases as we go to the right on the periodic table because the effective nuclear charge increases. So sulfur has 1 more proton than phosphorus. That increases its nuclear charge. And therefore its nucleus exerts a stronger attraction on its valence electrons than does phosphorus. And so the valence electrons in sulfur are pulled closer to the nucleus, giving it a smaller atomic radius. Now you don't have to write all of this, like if you were doing your answer on the actual AP exam, you don't have to write down all of this. I'm just sort of laying out some context so my reasoning makes sense to you. Now you will kind of want to do something similar to that in writing your answer. You want to kind of, obviously reference Coulomb's law and sort of give a little bit of context that the reader can follow your answer. But this is a sample of what I might write to thoroughly answer this question without, explaining on and on and on. Try to keep it succinct enough, but also be thorough. So part B, phosphorus has a larger first ionization energy than sulfur. Explain why this is. So this is actually opposite of the typical trend. Typically, ionization energy increases as we go from left to right, meaning sulfur would have a larger first ionization energy. And that's because it typically happens because atomic radius decreases, and smaller atomic radius means that the electrons are closer to the nucleus and require more energy to be removed. But there are a few exceptions. And this is one exception, like between phosphorus and sulfur. We would also get a similar thing occurring between nitrogen and oxygen, which are directly above phosphorus and sulfur. We need to consider their electron configurations in orbital diagrams. So these are the electron configurations for phosphorus and sulfur. And if we draw the orbital diagrams of their 3p orbitals, this is what phosphorus would look like, and this is what sulfur would look like. So phosphorus has kind of an especially stable orbital diagram, having a half-full 3p sublevel and 1 electron in each of the 3p orbitals. That is a relatively stable. And so to remove an electron would kind of disrupt this and would destabilize it, whereas sulfur doesn't have an especially stable orbital diagram, and in fact, if it lost this 1 electron, that would make it more stable, because then it would have 1. It would essentially, if it lost 1, it would obtain the orbital diagram that phosphorus has. So there's this exception that happens, and again, the same thing happens between nitrogen and oxygen, where oxygen actually has a smaller first ionization energy than nitrogen, and sulfur has a smaller first ionization energy than phosphorus, due to the stability of their orbital diagrams or electron configurations. So again, this is probably what I would write to justify that. And I think I would also sort of draw out these orbital diagrams the way I have here on my answer to make it clear to the grader that I know what their orbital diagrams are, and just as a reference so that the explanation makes a little bit more sense. All right, and then part C, we're looking at the photoelectron spectrum for phosphorus, and it's asking us how the photoelectron spectrum of sulfur would differ in these two aspects, the height of its rightmost peak and the location on the horizontal axes of the peak corresponding to the 1s electrons. So first of all, just so you understand how to interpret a photoelectron spectrum, the different peaks correspond to different energy levels / sublevels. So like in this case, the one farthest left, which on this diagram, if we look at the x-axis, that the leftmost one is the highest binding energy. That's the 1s, okay? Because the electrons that are closest to the nucleus are hardest to be removed. They require the most energy to be removed. That's essentially what binding energy is. So this would be the 1s, and then 2s, and then 2p, and then 3s, and then 3p. And then the height of each peak is corresponding to how many electrons are in that sublevel. So notice 1s and 2s are both the same height because they have 2 electrons, and then 2p is quite a bit taller than 2s. Looks like about 3 times taller, which makes sense because p holds 3 times as many electrons as 2s. So looking at this, it seems that the electron configuration is 1s2, 2s2, 2p6, 3s2, and then 3p, probably 3, estimating based on the height, which, is what it should be considering that this is the photoelectron spectrum for phosphorus. Okay, so that doesn't really answer the question, but that's just giving you a little bit of context if you're not familiar with what photoelectron spectra look like. But actually answering the first question, so the height of the rightmost peak for sulfur, well, the height, again, is based on how many electrons are in each sublevel. So we already looked at the electron configurations for each. Phosphorus ends in 3p3, sulfur ends in 3p4. So sulfur's rightmost peak would simply, it would be taller than phosphorus's. Okay, and notice in this question, it doesn't ask you to really explain or justify your answer. It just says identify how it would differ, if at all. So this is a perfectly fine answer to just say it would be taller, and you don't really need to explain that, okay, for this part. And then the location on the horizontal axis of the peak corresponding to the 1s electrons. So we mentioned the 1s electrons are here on the left. Now, the amount of binding energy for sulfur would be more binding energy, simply because sulfur has more protons and therefore a greater nuclear charge. Okay, so because the binding energy would be higher for sulfur, that on this diagram, higher binding energy is to the left. So it would be shifted to the left. Okay. And again, note that even though there was the exception for first ionization energy, okay, that wouldn't apply here because that was based on losing their first electron that they would lose. Okay, there was the exception because they had different electron configurations. But here we're just comparing the 1s electrons for each. So that's more of an apples to apples comparison. And the only thing that would affect the amount of binding energy for that is the number of protons. Sulfur has more protons, so it'd be a higher binding energy. So it'd be farther to the left.